And good evening, everyone. So, as James said, American Express sponsoring this evening. I'm from American Express. This is actually my personal experience through battling complexity and technical issues. From waterfall to agile, monoliths to microservices. Hopefully it'll be a good story and you'll enjoy it. I'll be available at the end for questions. There's also some of my colleagues here as well if you want to talk to us later. So this is a story of what happens when it all goes wrong and how to recover. Like it's going wrong now because the slide isn't moving. Yeah, I think it's the HDMI cable again. So while we sort this out, a little bit of background about myself. So Daniel Wood, I'm Technical Director for Foreign Exchange Solution American Express. And I'm so technical I can't get the slides to work. You'll notice there's a bit of a delay on here.
Not frustrating at all.
Almost there, almost there. Oh!
Come on, winner! Yes!
Excellent.
Okay, is the clicker working? No. Apple, it just works.
Or go to the bar at the bottom and quit.
That works.
That goes on there. So, been in technology for about 20 years, specializing in architecture at scale, agile change, and of course Java. So this is a Java meetup today. You'll notice there's a lot of references to some of the challenges we've had. The information here isn't necessarily in chronological order. It's just really going for the past few years, how we battled things and how we've moved forward. So what's the story about? Well, it's recovery from technical bankruptcy. What's technical bankruptcy? Well, it's really multi-dimensional technical debt. It's people, process, technology, environments, and strategy. It's not Donald Trump. He's just not very technical. So, in the beginning, picture of the Death Star. Really, the system is known as the Death Star. So this system, so complicated, the data model that you could generate from this actually look like the Death Star. It's very spherical, blob in the middle, some satellites around it. Why was it so complicated? Well, it's a system of over 1,000 tables, 1,700 stored procedures, 700 functions. That's just the database part. That was just Oracle. On top of that, there was Java code, Java 5, running it on IBM WebSphere 6, 32-bit Java. Lots of duplicate code, lots of dead code, not very much automation, defects in the database that were fixed in the Java code, multiple pathways through both the Java and the database, so lots and lots of functionality, very rich system, but a bit hard to deal with. Oh, and did I say there were multiple versions of the code base, 16 live in-development versions when I joined. Ouch. So the technical strategy as well. So we've moved on from this. This is probably a little bit unfair, but there was a love for IBM. I've already mentioned WebSphere. Well, the strategy was to move from Oracle, a PL SQL Oracle application running on IBM WebSphere, to IBM packaged products running on IBM DB2 on a mainframe. So this is a Java talk, not a database talk, but fundamentally, Oracle PL SQL, not compatible with DB2 on a mainframe. Defects took anything from 3 months to 6 months to fix, and the release cycle was about 18 months from just the prioritized piece of work to it getting shipped into production. So a lot of pain, a lot of difficulty, a lot of challenges. So really back to basics. I struggled to get a picture for this slide. I thought, how can I represent going back to basics? This was the closest I could find. Lots of wiring and spaghetti. So really, there was a lot of challenges, all duplicate code, dead code, bad environments. You really need to unpeel that and understand what the system is to really understand where the value of the system and how to take it forward. Why was I doing this? Well, it's profitable business. Hundreds of thousands of transactions, billions of dollars flowing through the system, lots of want to improve it, lots of want to change it. It was just very hard to do, and it took a very long time. So look at the business, look at the system, look at the domain, look at the language, look at the people, and really, so story of discovery and making sense of complexity. So technical debt wasn't because this system wasn't valuable, it's just because lots and lots of good people just didn't really have the technical knowledge of how to make it sustainable. And really there was a significant alignment, not just from strategy, but to technology and product, all the way through to sales. So lots of people trying to pull in different directions, lots and lots of requirements, and lots of demands on a stretched team who really didn't have any technical guidance. So as I looked through this, and it wasn't just me, it was colleagues as well, I looked at the language that people were talking. So you may ask what a payment is. You may ask what a supplier is or a beneficiary, what a payee or a payer was, what a foreign exchange is, what's a currency. There were different terms for different parts of the system that all meant the same thing. Or in fact, there was one term, what was it? Payee, payer, beneficiary, supplier, they all meant the same thing. So really trying to get to grips with what these terms were in this morass of complexity, taking it down and distilling it. So there's a lot of workshops with product people, technologists, trying to understand the language, trying to understand the purpose, starting to unpick the terms in the system, unpick the Java code, looking for patterns in the language, looking for patterns and seams in the code base to try and unpick this together. This led to doing a simplified view of the system, breaking it down into functional domains. You might even say this is an element of domain-driven design, finding areas that could be changed independently and really giving the business the capability so that they could grow and change the system much faster than the sort of 18-month, 2-year turnaround that they were looking at that time. So there were reasons behind this. Teams needed to understand and get a shared understanding of dealing with the complexity. As I said, there was just enough design to work through this and start breaking this down into the bounded context, into the domain. So you might even guess where some of this is going now. Not really copying all the patterns and language around microservices out there, but really to frame the next set of work so that we could enable a scaling business. So as I said, this is all based around looking at the language and looking at how people work. And this is analogous to what we ended up with. So it's not thousands of tables, it's not a big morass of complexity. It's more looking at the business terms and the business model for the system. So this is simplified. I've taken some key bits out just for confidentiality. But where this breaks down is from a business perspective, the system is very much based around a client user interface, a business servicing user interface. If I can find the light, which I won't do. Web services, which was soap-based file processing. Some consumer-facing business behaviors. So this is a foreign exchange solution. Users can come in, they can get their currency, say maybe UK pounds, they want to make a payment in US dollars. So we need to understand some element of who they're making the payments to, how they're doing the FX quote, the currencies, how they're facilitating the payments. And you notice there's nothing around technology here. This is not around Java, this is not around database, this is just taking the terms and the language and breaking it down into things that all the stakeholders, no matter what their background, could understand, language that they could group together and work through. And behind this model were also very high-level sequence diagrams, really, again, peeling away the complexity of the platform and saying, as a user, when I want to make a payment, I flow through these systems. As an operational person, as I go through this system, I can do these approvals. Now, why bother with doing this? You may ask. what's the purpose of this? So when you go about this model of looking at the design for developing the system, you can start to identify the root nouns of the system. Those root nouns can then become APIs for the business behavior behind the system. You can start then encapsulating the business logic around them in unique bounded contexts, packaging up the code. You can then deploy that code, build and test and deploy that code separately and ship it out. Again, small chunks of work away from the big scary monolith that's just off the side of the screen. Now, the nouns aren't telling the full story. As a user, you might do something to a noun to get an action. They're really the verbs, they're the behavior. So as a client, I might be going in, I might be creating a payer, I might be creating a beneficiary, I might be going through an approval, I might be capturing a quote or creating a payment. That's the information that you then express against that API to get a behavior. You can build tests around it, and it becomes much more valuable to everyone. Now, as I said, the behaviors live inside the boundaries. Actually, in the model we move towards, some of the names would live across boundaries, but within each boundary, the behavior is unique. So I'll make an example up here. So no, I won't. Do we have account in two places? Well, let's say for a moment, a client has an account, an accounting has an account. Those nouns are the same, but the behavior in the different contexts is different. A client account is an account belonging to an account to themselves. So James may have an account, that's his personal account that he might be paying Alistair. The systems account might be where they're collecting James's money and then paying off another organisation on behalf of that payment to Alistair. So same names, different behaviour, different context. Do I dare press the screen? Okay. Now, how do we get from the previous slide, or this slide with all that complexity, to delivering in this way? So, as I said, there were 16 versions of the code. There was no automation, no deployment pipeline, just some boxes with some words and some concepts behind them and a vision. So there's lots of impediments. So a lack of understanding around why bother with deployment automation when it takes 18 months to release? Why bother with test automation when you have to check everything because all the environments are inconsistent? Bringing people on this journey took a lot, it probably was half the battle, or more than half the battle. Putting in the build pipeline and Jenkins and good practices was simple to do. Once you got where is the slide? Okay, once you got to a single version of the truth. So I took this slide out of actually something I produced when we started going down this. This is an example from how we merged the code. So Subversion at the time, we've now moved on to Git. That's a different story. But this was just merging down all the code bases. Now, within each of these different branches, again, different duplicate versions of the code. Some, for example, the Project E might have been branched off mainline 8 years ago. Project D branched off 4 years ago. Lots of divergence. Trying to get to a single source of the truth was very challenging. So this is where the journey to simplicity really began. Building out tools to look at the history of the code in source control, trying to understand really where was the truth in there, which parts of the system had lived for the longest, which parts of the system had gone through the most significant change. From that analysis, we could then build out a plan to start merging it towards getting a single structure. Interestingly enough, although we had 16 versions of the code, when you actually got into the detail, You were changing a class here, or a package there, or a module over here, or a dependency there. They're all over the place. They're all independent, so they didn't really conflict. So with that piece of information in place, merging things down became very, very easy. But yeah, beginning to unpeel some of the unnecessary complexity was an interesting challenge. So it's very much belt and braces at the start, bringing in Jenkins, bringing in a level of build hygiene, looking at how we did automation testing. So along with the manual process of deployment, the manual process of building the code, there was manual testing. So some of this still exists today, but it was really looking at the manual test cases, all however many thousand of them, building out Selenium test cases and then adding that on top of the monolith. And I still use the analogy today that we're covering the old system around in bubble wrap to protect it while we build out the new system in parallel against it. So we'll come on to how we had some support. So put this together for my children, actually. They were really excited about the Star Wars theme underneath this. So at the start, it was myself and a group of offshore developers and really some technical, non-technical project managers. And you can't really do all this work without a strong group of rebels to destroy the Death Star, as I put there. So there was a lot of effort put into recruitment. At one point, there were 150 people offshore, and I think 20 people onshore and 2 technical people, including myself, onshore. That's now shifted where we have the majority of the developers working collaboratively with product, with testing, fully co-located here in the UK, just up the road in Burgess Hill. That took a lot of time and a lot of effort to really recruit and get the right caliber of developers in place. So some of my colleagues are here this evening. You can talk to them about experiences at Amex. I'll leave you to have those conversations, but I put a lot of effort into making sure we have good developers, and I hope that's seen through in where we're going with the teams. And so at the start, as you bring more people in, as you've all thought here, looking at this complexity, it's like, there was really a measure. This was the measurement in my head of where we were to how we've come, and I think actually the commentary has gone down, and there's now much more consistency on getting better. But probably for a good 8-9 months, it was, oh my God, I can't believe what I've just found. Case in point, so merging the code down to a single bit of single code base. Started unpicking really database connectivity issues. Servicing system, the client system, the SOAP system, that they tackled different parts of the platform, all talk to the database via JDBC, all via stored procedures. What we discovered, can I even say this in public? Oh, I'm going to now. That with JDBC, especially with the sort of stored procedures we were looking at, normally you bind the variables to the stored procedure, so you can say variable A is an ID, variable B is a name, blah, blah, blah. Now, when you've got PL SQL signatures of 16, 17 inputs, and probably just one output, so the result set, and that's changing frequently, some developer in their wise mind a long time ago thought, oh, you know what, I'm just going to switch off the checking, and you might put in 15 attributes or 18 attributes into a signature that only accepts 10. And of course that wouldn't be picked up in testing, that wouldn't be picked up in automation, would be picked up in production by a customer. So that's really an example of where we were and now where we're getting to. So those sort of things don't happen. We've got code reviews, good clean practices, actually where we've removed the use of stored procedures for anything new. Now using JPA and inline SQL for that, which is good, and things are getting better. Good, clean, repeatable, practicable, common patterns. Wrong button. So early on, I talked about the different services, the nouns and the naming. This is how it came into use. Some of you may be aware of this. There's a pattern that's been around for about 10 years called the strangler pattern, and it really works like the strangler fig tree that you find in tropical forests. You start with your old legacy system, you build some new code around it, and that slowly entangles the rest of the system until the old system has disappeared and it's replaced with the new. How did we do that? So, the nouns, the bounded contexts, they were separate deployable microservices. REST APIs, individual code, you could test at the interface, deploy them, it's all good. Challenge was integrating back into legacy, and we made some mistakes there. And we learned from that, and we got better. So we started off with a concept of what was called an integration API. Integration API to REST API sat on top of the legacy code. And you could talk to it via REST, that's good. What we didn't realize is new code, Java 8, all nice, fluent interfaces, lovely, old code, Java 5. And dependencies, and lots of dependency challenges to get the code working correctly. And I think we worked through that, and it's hard work. So I'd say really we're sort of in the middle stage. We've still got some legacy in place. Over the next 18 months, would have got rid of that. We've now changed the way we integrate with legacy, and I think this is a good lesson for a lot of people if you've got similar experiences, or even if you've got other monoliths you need to connect and strangle away, as illustrated here. So there's some other patterns here called seams. And I think there's Martin Neingard did a book, 2008, called Working with Legacy Code. In that book, it talks about seams and how to understand seams. So a seam effectively is an interface to a system. Now, that interface could be a database, JDBC, PL SQL, it could be messaging interface, just be a class. We took this as a stored procedure and added a MQ, an Oracle queue on top of it. But the principle is the same. You take an existing interface, you change the way it's called in, and you get an expected behavior out. So what we've done is we've taken, by and large, some of the front-end behavior out, we're putting more information in, and we're now beginning to unpick and take other information out from underneath. So slowly strangling away the system. Now, seams are a bit challenging at first, conceptually, to get your head around, because you're not really changing the legacy code, you're just working around it and obstructing how it's executed, but leaving some of the underlying behavior. On top of that, with this sort of embrace, extend and extinguish model, adding in feature toggles. So you're probably all aware of feature toggles now. When you're releasing continuously into production, you can switch on code on demand just by changing the switch. So seams, feature toggles help us de-risk what was a challenging deployment process, and again, it's getting easier. So this all drives towards incremental implementation. Yes, at the start there may be an 18-month lead times to get functionality through, and yes, okay, now we might be breaking that down and releasing major functionality in 3 months, but we're still releasing into production every 2 weeks. We've still got automation and validating those changes every 2 weeks. We're just de-risking those, enabling it with the feature toggle. So we can choose now when we enable functionality in production rather than doing it in a big bang approach at the worst possible time, which is whenever you do a big bang release, in my opinion. So smaller units of change through bounded contexts, strangling the legacy away. So what are the bounded contexts? I've talked a lot about these. We've gone down the model of ports and adapters. This isn't actually a very common pattern from talking to a lot of the team I've discovered. So ports and adapters are really the way of representing how you execute behavior in a bounded context. So here, simply, this represents 3 bounded contexts on the diagram. They're all talking via a messaging interface. But the principle behind this is encapsulation of your domain logic in domain named objects. So on the previous placemat diagram, there were things like quote, currency, payment, account. That's how you name your domain objects in the system. So you would have an account object. It's immutable. It's within it, you've encapsulated all your business logic, so there's no layered servicing. It's all within the center, it's all within the domain. Surrounding the domain in this, you've got your commands and your events. Now, a command is really a request to make a execution, a request for something to happen. An event is a record of that activity happening. Typically, with domain-driven design and development, the business logic's encapsulated in the domain objects. As I said, they're built, because it's Java, with builders, built to be immutable. So you're setting up those domain objects to be into a given state. You're computing that action from the command, so storing that in the event, and then going off on your happy way. So the domain is where everything's stored. The commands and events around it are triggering or requesting activities with your API and your interfaces around the edge. Now, at the bottom, persistence. A common mistake when working in this way is, domain-driven design, hexagonal architecture. We'll have our domain objects and our domain objects, and they're the same. You can't have a domain object that represents a database as well as a domain object with your business logic in, because there's no way of computing that state from the command or the event and storing it. They're not the same thing. So what we've developed is really a packaging structure going down into this, then to separate this out. So domain behavior, domain model is at the top, separated out by your ports and your adapters. And in here, you've got, in this example, you've got a quote as an interface in, triggering a quote command that sets up your domain, gets the quote into a given state, that then triggers off a storage down into a persistence model that may be different. So let me unpack that for you. A quote, in this example, a quote domain entity, when it's set up via its quote builder, in this example. You're setting up, you're saying for a quote, for a user, I'm giving it an in currency, an out currency, an exchange rate, calculates all that information. Great. You've done your calculation. You then take that calculation and you store that in the database. And maybe as a JSON format, and maybe in a traditional relational format, but it's different. Relational model is different to the domain model in the code. They're very different. And the purpose around the ports and adapters is to enforce the separation of concern. Every one of the adapters around the side has its own personal model of how it views the world. They're really your anti-corruption layers. And the domain model inside is how you represent your business logic and the execution of your business logic. So your persistence model is different from your messaging model. It's different from your web service or user interface. So why go to all this bother? You've had all this unnecessary complexity over here, and now you're reinforcing very strict rules on how you structure your code down at the micro level here. Why bother? Well, this has some good positive side effects. Reinforce the need for small changes. You can then start recording in unit tests and integration tests the behavior of your business logic in very small executable ways. Fast feedback. Don't need to spin up everything, and now we've got good things like Spring Boot. It's easier, but you can do that just in your in IntelliJ or in via Maven or Gradle. So you don't have the expense of setting up your environment and running it. You can do quick iterative development, quick test-driven development, as you were talking about at the workshop before. So there's a productivity boost. You don't have the cost of dealing with all the old legacy infrastructure. You don't validate, quick, fail, fast, learn, show and tells to the product owner. Everyone's happy. It's all common language that product owners and QAs can read because it's all written in a very, very domain fluent manner. So I'll make this up now, but quote equals quote builder dot create quote with currency UK and US compute. It would generate a quote for that state. Now, the other side effect of this, when you're dealing with large scalable systems, is you can rely on the computation of the cloud, or in our case, an internal cloud system, the horizontal caching for the persistence and the storage, and so you can then enable horizontal scale very quickly and execute the business logic in very short-lived immutable classes, but storing the information for long-lived in a shared cache horizontally. So if I take you back a moment to now that the slides are working correctly, back to the start. So going up a level, everything along the top, these become horizontal, scalable computation. It really is a gateway into the system, with each one has its own shared cache underneath, separated out by an asynchronous messaging solution, which we haven't implemented yet, but we'll be moving to Kafka in the near future, providing the asynchronous connectivity to all the back-end payment processing systems that we need to deal with. So you can scale very quickly. You've got the fast iterative development through the domain-driven model that we talked about. Everyone's happy. And you're slowly eating away at the tree until you get to the end. So we're not there yet. There's still plenty to do. If I'm honest, we've not really chipped away at that. But what we have done is taken a lot of benefits from the business and automated them. They're getting value quickly. There's a fast throughput of change. And to be honest, we'll never really get rid of that. It will just make it less useful. It will go away because we have built out scalable services for the business. And we can solve problems much faster than having to deal with that system, because the monolith will be completely covered in bubble wrap. And then it can just disappear gracefully into wherever monoliths go to die. So some other things as we go on. These are patterns that are useful now and go forward. So some of you may be aware of a concept called consumer-driven testing. It came out of I think an estate agent company in Sydney a couple of years ago. So if you Google Pact and Pact JVM, this is really, I didn't make this diagram, it's directly from their website. Pact JVM is consumer level API testing. What is that? Why is it valuable? So if you imagine for a moment, I'm not going to flick back, but you've got this scalable horizontal API at the top. You've got many consumers of that API. You don't want to change it. Change is bad because it ripples down to all the consumers of that API. Pact allows you to make backward compatible API changes, so you can change inside your boundary and make the consumers outside your boundary very happy. So the way this works is with a Pact verification process. So you take your API, you run your test with Pact, you can generate your Pact file, and then that can be run against any consumer and vice versa to make sure each side is compatible. I would say it's more important for the provider to make sure they've got backwards compatibility, as you're changing things there, probably less so for the consumer because they can go back to the original endpoint and validate. Very useful pattern, and I recommend if you do anything around API and versioning, have a look at Pact in a deeper detail. So what else do we do now that we didn't do before? Well, Cucumber. There's various flavors of fruit and vegetables out for testing now. We've got Cucumber. It works just very well. That really has acted as the glue for the domain-driven language that we're trying to encapsulate in the code to the language that the teams use and the product owners, taking the acceptance criteria and making it executable into the code base, giving us an ongoing regression as we build out new services. Now, we're also now beginning to explore Spock. I first looked at Spock a couple of years ago. I was slightly didn't really get what it was all about, and actually now the team are beginning to explore that more, and I can begin to see the value after originally being sort of on the fence about it. So Spock is really the power of acceptance, cucumber type BDD, but at the unit level, doing much better data-driven tests. You don't end up having reams and reams of unit tests. You can just have a very nice descriptive unit test with some data elements, and again, down to that fail-fast process. Sadly, we still have some of the legacy regression framework based on Selenium, but again, that's slowly going away. So we've not really talked much about reusability. And yeah, you can have a read of that if you like. So reusability in the old world, there was a ton of functionality, code reuse gone wild, dead code all over the place, duplicate code. It was really code reuse abused and used in a very bad way. And now we're moving towards the microservices world. Everyone says, how do you do code reuse with microservices? Well, the answer is you don't. You want to make sure you've got reuse of the system at the API level rather than in the services. If you start doing code reuse across the services, that's a form of coupling. If you make a change to that shared library, it ripples down to all the services using it, which isn't necessarily a good thing. I've gone down with the approach, and I've used this a few times now, not just with this platform, but if you have to copy code across services, it becomes code that lives in that new service. It's similar, it's not quite the same, but you're making a conscious decision to copy it and alter it in relation to the context that you're looking at in the separate microservice. Now, you only really end up needing to do code reuse like that for utilities like security or logging, because you're building out the services in a domain-driven manner, and you're encapsulating logic in there. So actually code reuse, to a degree, doesn't go away, but it becomes less important. And again, you don't strive for reuse, you just make sure that you're reusing across the API. So where next? Well, there's still lots to do. We won't get rid of the legacy, we never will. We're in the process of moving to our internal cloud system, which should be an enabler, and it will be an enabler. There's just a few teething issues. And yeah, I think the key thing is getting improved information out of the platform, more business value, improved logging, statistics, and usage, so we can make more informed decisions. The technology, the teams, the process are all in a good place now. It's actually now getting more value out of this, and actually doing sessions like this with other teams internally, and actually sharing these ideas and patterns and trying to improve the work for everyone around. And then that feeds back into, again, the build, measure, learn cycle that we're beginning to adapt in the team. So it's continual learning and continual improvement in a very meaningful way. So again, I'm Daniel Wood. That's presentation over now.